Cos 2x can be written as 2 cos square. So 2 cos square x minus 1. This means the term cos square x actually, or 2 cos square x, is same as 1 plus cos 2x. We are carrying this negative 1 to the left hand side. So 1 plus cos 2x is 2 cos square x. Now we will be using this identity to integrate cos square x. All right, let's write this I. We want 2 cos square x. This is 2 cos square x there. So we are going to multiply and divide this expression by 2. Divide remains outside, integration, and 2 cos square x dx. Now 2 cos square x can be written as is equal to half and integration sign as it is, and 2 cos square x, it can be written as 1 plus cos 2x, 1 plus cos 2x dx. Now we can write the integration of these two terms. Integration of 1 would be x, integration of 1 is x, and plus integration of cos 2x is cos, integration of cos x is sin x, so sin 2x in this case. And just like in differentiation, we used to multiply by the derivative of this function, that is 2. Here we divide by the same number by the differentiation of that function and plus c. So that is your answer. So integration of cos square x is equal to half. We can open the bracket and write it clearly. So if you open the bracket, that would be half x plus 1/4 of sine 2x, sine 2x, and plus c. So that would be the integration of cos square x. Next question here is integration of sine 2x cos 3x. So identity which is similar to this is 2 sine. See, we can also write this is equal to integration of, can we write cos 3x first and sine 2x later, just to avoid the negative sign. In fact, product is commutative, so multiplication is commutative, so it will not make any difference in the question. So question can be written like this. But the identity we are going to use is 2 cos A. 2 cos A cos B. Look, 2 cos A cos B is equal to, let's write this, because this is the identity we're writing. This is equal to sine of A plus B. Now these identities we will write some few times, will become means you will learn them by heart. Sine, first you add both angles and the next one you subtract them, right? Sine of A minus B. So we need 2 cos A cos B. For that reason, we are going to divide and multiply the given expression by 2. So our question, if we represent this by I for integration, so it looks now like this. Now 2 cos A sin B, we are writing it this manner 1 by 2 as it is. And integration of 2 cos A sin B means first you add both angles. So 3x plus 2x is 5x. So sin 5x minus sin 3x minus 2x is x. So can I directly write it? Sine of 5x minus sine of x and dx. Now we can open the bracket, so it will look like half time integration of sine of 5x, sine of 5x dx, and minus half integration of sine x dx. Okay. Now integration of sine is negative cos, and again see this is 5x, so you will divide by the differentiation of this 5x. There are two ways. You can also do it by substitution, taking 5x as t, then 5 dx equal to dt. So then dx equal to dt by 5. So obviously that 5 will appear in denominator. So you can also write it straight away. So it would look like 1 by 2, and integration of sine is negative of cos 5x, and you are also going to divide by the derivative of this 5x, which is 5, and minus half, and the integration of sine is again negative cos x and plus c. Finally, you would like to write your answer multiplying these two. So your answer would look like 1 negative 1 over 10 of cos 5x, and negative is positive, positive 1 by 2 cos of x plus c. So this is the way we use trigonometric identities to reduce our trigonometric function in a form where we can integrate it easily. All right. We will take one more example, one more warm-up question. Sine cube x dx. Let's write I is equal to, I for integration, I is equal to sine cube x dx. So what we are going to do is we we can do it all this question also two ways. One, we can apply the formula of sine 3 theta and then separate sine cube x and integrate. The other way is like you can write sine cube theta as sine square theta, theta is x here, sine square x into sine x dx. So this is sine square x. Now the first function here can be changed into cos. So we can write this is equal to integration of sine square x is equal to 1 minus cos square x. All right. Sine square x is 1 minus cos square x times sine x dx. Now it must become clear to you also. Now if you put sine x, put cos x is equal to t. Now put cos x is equal to t. This is going to give you sine x. Derivative of cos is sine x dx. Is that negative sine x? Yes, it is negative sine x dx is equal to dt. Differentiation of cos x is negative sine x. That means sine x dx, this function over here, sine x dx would be negative dt. So can we write here sine x dx is same as negative dt. Okay, so next our integral now would look like this. Integration would be equal to integration of 1 minus t, cos x is t, so this would be 1 minus t square, and sine x dx would become minus dt. So it's time minus dt, right? So it's multiplied with this. This is this can be written as minus of 1 dt. Okay, and minus minus is plus, plus of this is t square, minus minus is plus t square dt. Minus of 1 with respect to t, integration of minus 1 would be is equal to minus of t and plus integration of t square is t to power 2 plus 1, that is t to power 3 divided by 2 plus 1 and plus c. Of course, we would like to change our answer or express our answer in terms of x. So we are going to retain the value of t. Here it is. And what is the value of t? The value of t is equal to minus of, in place of t, we are going to write cos x plus cos cube x by 3 plus C.